Hi everyone. Welcome to the video lecture series on field theory. And in last class we are discussed about type of coordinate systems, and today we are discussing about last type of coordinate systems and points to remember. And finally we are moving on with the problems. Okay, come let's go to the video. Here now what we are doing is here now. Sorry. Here now what we are going to do is what points to be remember. So we have seen what is three types of systems, that is Cartesian system, cylindrical system, spherical system. So its coordinate is x comma y comma z for Cartesian, r comma phi comma z for cylindrical, and spherical r comma theta comma phi. Okay. So difference in current I1, I2, I3. So difference is dx1, dxy, and dz. And for this is dx, r, d phi, and dz, z axis. And this is r, dr, r, d theta, and r theta sine. Okay, the volume element is dv is equal to di1, di2, and di3. So multiplication of di1, di2, and di3. If a volume changes density rho, volume changes density rho, it depends on only on r. It depends on only on r radius, radius. So here we can see so charge q is volume integral of rho into dv. So total volume integral of rho particular space. So that is one to the line integral as rho into 4 pi r square d r, 4 pi r square for in terms of length. For example, for circular plane, note the area element dA, the difference in area, dA is equal to r into dr d5 in the both coordinate system, because angle theta with is 90 degree. Angle theta is equal to 90 degree. Angle theta is equal to 90 degree. Okay, so that's what the points to be remembered in this unit chapter. And here the volume integral surface, one is finally the solution for this is finally solution here comes the volume covers by the surface. Here what you are doing is the solution is first solution S1 is flux phi 1 to phi 2, that is r into d phi, that is 0 to h, that is 0 to height 0 to h dz, sorry, dz, that is r h into flux phi 2 by phi 2 minus phi 1, that S2 is equal to 0 to r, with represent to S2 surface area, that is 0 to h, that is r into h, which represents to height S3 flux phi 1 to phi 2, and r0 to r, that is dr into r d theta, that is r square by 2, that is the flux phi 2 by minus phi 1. So here the volume integral for r theta angle, everything is at r theta is at. Okay, so r square by 2, that is phi minus phi 2 minus phi 1 into h here. So the radius of the r, that is height is the radius is the r, the height is h, and the flux phi 1 is less than equal to 5, and then less than equal to phi 2. That phi 1 is less than equal to 5 is represented between phi 1 and phi 2. Okay, so this is what points to be remember. And next we are going with a problem. Here the problem is problem is a cylinder with the radius of rho and a length L. The radius of cylinder with the radius of rho and with the length L. So determine the volume enclosed and the surface area of the volume. Determine the volume enclosed and surface area of the volume. So first we can say the volume enclosed with integral. So volume, we know that volume integral of dV. So difference in volume. So we know that volume rho is equal to 0 to rho, and phi is equal to 0 to 2 pi, and z equal to 0 to length L. 0 to z axis is length L, 0 to rho and 0 to 2 pi. Okay. So here we are taking integral. So phi into d phi, the d rho and dz. So we are taking volume integral. So rho square by 2, that is applying upper limit by lower limit for each differentiation. So we are taking separate differentiation for this and each differentiation. And finally, rho square by 2 into 2 pi into L. So rho square by 2, this pi, so rho square by 2, this 2 cancel, get this 2 gets cancel. That is rho pi rho square into L. That is volume V equal to pi rho square into L. So this is what volume integral. Next is for surface area, we added the area of, for surface area, we added the area of, so first surface area, we added the area of two areas, that is d phi and dz, plus we adding separate two areas, flux phi and dz, everything. Finally, we are getting this answer. So 2 pi into rho L plus pi rho square plus pi rho square, that is 2 pi L plus 2 pi rho square. Finally, the surface area is equal to 2 pi L 2 pi rho square. Okay. Today in this class, we are discussed about problems, points to be remembered in coordinate system and problem in coordinate system. In another video, we can discuss on some other problems on coordinate systems, etc. Thank you so much.